This is section 10.4. We're going to find areas of triangles and trapezoids. You've done this before, and we actually did this the last 2 days. If you want to find the area of a rectangle, you could just count the blocks in the rectangle and however many blocks are in it. If you want to find the area of that triangle, it would just be half of it. If you draw a diagonal on that rectangle, those two triangles are going to be congruent. So the area of that triangle would just be half of the area of the rectangle. That's how we're going to find the area of triangles today. We're going to use a formula, and notice how the 1/2 is in the formula. You're basically taking half of the area of a rectangle. So if we would do what we did the last 2 days and just box in all of our triangles, that triangle would take up half the area of that rectangle. So we use the formula 1/2 base times height. Your base and your height are segment lengths, and those segments are perpendicular to each other. So notice how the base is that blue segment at the bottom, and the height is the segment that's perpendicular to it. It just so happens to be right here. Perpendicular meaning it makes a right angle. So whatever those two lengths are, you multiply them, and then you take half of that. That first triangle is acute. Notice where the height is. It's inside the triangle. If you have a right triangle, the base and the height, remember, have to be perpendicular. So we have our base down here. We have our height, and it's actually on the triangle. When you have an obtuse triangle, like this yellow triangle over here on the right, the base is that side length. The height actually isn't even a segment of the triangle. It's that segment that's perpendicular to the base, but it's not the side of a triangle. So it's like an imaginary vertical distance. When you have an obtuse triangle, that height is outside of the triangle. And you're going to see examples of each one of these different types of triangles. And you're going to have to find their area. We'll do an example of each. So the way this is set up, the first triangle is acute. The second triangle is right. And that third triangle is obtuse, just like our previous slide. If you want to find the area of the triangle, you're going to write down the formula, and you're going to plug in the base length and the length of the height. So we want to do 1/2 times 12 times 8. And that might seem really, really tricky. If you know 12 times 8, you can just take half of it. If you don't, you could type it in your calculator, it will give you the same answer. But you could also do 1/2 of 12, which is 6. And you could do 6 times 8, which I think everybody should know is 48. Just don't forget your square units. On the right triangle, you use the same exact formula. Your height is just in a different place. The height is on the triangle now. So half of 5 times 6. We know 5 times 6 is 30. Half of that is 15. Again, make sure you square your units. On that one, it was easier to multiply the 5 and the 6 together and then take half of it than taking half of 5 times 6. You could have also done half of 6, which is 3. 3 times 5 is 15. The trickiest one's probably your obtuse triangle. Be careful on this one. Remember, your base is that blue segment, has a length of 7. Your height is the segment that's perpendicular to that. It's the red segment, has a length of 10. The 2 is just a piece of information there that's trying to confuse you. It has nothing to do with the base or the height. It's really telling you that the height lives 2 feet away from the base of the triangle. That does not factor into the area of it at all. 7 times 10 is 70. Half of that is 35. So 35 square feet would be our area. In our next video, we're going to look at how to find